In this video, we're going to solve a challenging problem from the world of limits. This is the question. If the function fx satisfies this, evaluate limit x approaches 1 fx. We need to figure out what fx approaches to when x approaches 1, and we're given that this approaches pi when x approaches 1. And this is fx minus 2 by x square minus 1. Now pause the video, give this a shot, try this on your own. Okay, let's do this together. Let's analyze what's happening. What's happening at x equals to 1? What is the denominator at x equals to 1? Now at x equals to 1, the denominator is 1 square minus 1, that's 0, which is the problem. Now as we approach 1, the denominator approaches 0. What's happening in the numerator? The numerator at x equals to 1 is f of 1 minus 2. Alright? So the limit exists, which means whatever is making the denominator 0 is probably getting cancelled out by the numerator. What we're saying is, if the limit exists, numerator is somehow helping us fix the denominator around x equals to 1. Around x equals to 1, both of them have something that's getting 0, which means the hunch is that the numerator is also approaching 0 when x is approaching 1. So the hunch that I'm making here is the limit x approaches 1 fx is equal to 2. 2 minus 2 should approach 0. Now my guess is that whatever is making this 0 is also making the denominator 0, and both of them are getting cancelled, which is giving us this beautiful limit of pi. But let's break this down. Let's not take this hunch as our answer. Let's solve this. Alright. So we have the limit as x approaches 1. Let's break this down. Let's find the left hand and right hand limit of this expression. So the left hand limit will be x approaches 1 minus fx minus 2 by x square minus 1. That's equal to pi because the limit is pi. Both left hand and right hand limit will be pi. Now let's substitute. Because we're finding the left hand limit, let's treat this x as 1 minus h. H is a very small quantity which is making x very slightly less than 1. As x approaches 1 minus, h approaches 0 plus, something infinitesimal, something very small. Let's replace this. This becomes limit h approaches 0, f of this is x, so we'll replace this with 1 minus h, something slightly less than 1. F of 1 minus h minus 2 divided by x square, this becomes 1 minus h square minus 1, that's equal to pi. Spreading the limit in the numerator and denominator and then moving it around, we'll get limit h approaches 0 plus f of 1 minus h minus 2, which is the numerator, that's equal to pi times whatever is in the denominator. Now this is a polynomial and we can substitute h as 0. We'll get 1 minus 0, that's 1. 1 square is 1. 1 minus 1 is 0. So this entire thing is pi times 0, that's 0. So let's simplify. Left hand side is as is. This is equal to pi times 1 minus 0 square minus 1. This is pi times 0. This is 0. So if this is 0, limit h approaches 0 plus f of 1 minus h should be equal to 0 plus 2, taking 2 to the other side. So this should be equal to 2. If we're reading this correctly, we're saying that the left hand limit at 1 is 2. Left hand limit of fx at x equals to 1 is equal to 2. And using the same thing, we can find the right hand limit. Limit x approaches 1 plus fx minus 2 by x square minus 1. This is also equal to pi. Now we substitute x as 1 plus h. Here h is a very small positive quantity which is making x slightly greater than 1. X is approaching 1 from the right hand side. So let's substitute. This is limit h approaches 0 plus f of 1 plus h this time minus 2 by 1 plus h square minus 1. This is equal to pi. Now spreading the limit and cross multiplying, we get f of 1 plus h minus 2 on the left side, and right side is pi times the denominator. This is a polynomial, we can replace h by 0. This is giving f of 1 plus h minus 2 on the left hand side equals to pi times 1 plus 0 square, that's 1. 1 minus 1 is 0. So we're getting again 0 on the right hand side. Taking 2 to the other side, we get the right hand limit at 1 equals to 2. So the right hand limit at x equals to 1 is also equal to 2. What this means is the left hand limit is 2 and the right hand limit is 2. The left hand limit as x approaches 1 of fx equals to 2, and the right hand limit of fx as x approaches 1 is also equal to 2. If both the limits exist and both of them are the same, this means that the limit as x approaches 1 of fx exists, and that's equal to